Humanoid robots are no longer just a futuristic curiosity. They're starting to show up where the world's toughest labor problems are. And nowhere is that challenge more visible than in logistics. Now, with industry heavyweight UPS reportedly in talks with Figure AI to explore humanoid robot deployment, it's clear that humanoids are being seriously considered as part of the solution to real-world commercial bottlenecks. According to sources familiar with the matter, UPS and Figure began discussing a potential partnership last year, and those conversations have continued to gain traction in recent months. While both companies have kept official details under wraps, the implications are hard to miss. UPS, one of the largest and most sophisticated logistics operations in the world, is exploring whether humanoid robots can play a role in its future workforce. And this isn't just a passing interest. UPS moves millions of packages daily across a global network that includes everything from sorting centers and warehouses to last-mile delivery operations. These environments are highly optimized but still heavily reliant on human labor, particularly for tasks like loading, unloading, sorting, and handling packages in dynamic spaces. Unlike fixed industrial automation, which requires specialized infrastructure, Figure's humanoids are being built to operate in human-designed environments. That alone makes them a compelling fit for logistics companies looking to automate without redesigning their facilities from scratch. What makes this development even more interesting is the broader context. The logistics industry has been under constant pressure due to labor shortages, increasing e-commerce demands, and rising operational costs. Companies like UPS, FedEx, DHL, and Amazon have all invested heavily in robotics. But until now, the focus has largely been on wheeled robots, conveyor systems, and robotic arms. Humanoids, with their ability to walk, lift, and manipulate objects like humans, open up a whole new category of flexible automation. If Figure's robots can handle tasks like sorting packages, stocking shelves, or performing end-of-line quality checks with minimal retraining and adaptation, they could plug directly into UPS's current operations with far less friction than traditional automation solutions. That's a huge deal, not just for UPS, but for the entire sector. It suggests that humanoids aren't just science experiments anymore. They're potential labor solutions for billion-dollar bottlenecks. And UPS isn't alone in this interest. Earlier this year, BMW announced a pilot program with Figure to deploy humanoid robots inside its US manufacturing facility. That partnership validated the hardware's industrial potential and gave Figure access to real-world data that is likely helping accelerate the robot's learning and reliability. Now, if UPS joins that list, it would further position Figure as a frontrunner in the race to deploy general-purpose humanoids at scale. For Jeff Bezos-backed Figure AI, this kind of deal would be monumental. Getting a foot in the door at a company like UPS not only brings prestige, it offers a sandbox with thousands of workflows and millions of repetitions per day, perfect for refining robot behavior through real-world feedback. It would also give Figure a long-term customer that's deeply motivated to find scalable, adaptable, and cost-efficient labor alternatives. The timing couldn't be better. As governments and economists warn of aging populations and shrinking labor pools, logistics firms are preparing for a future where automation isn't optional. It's a requirement. But not all automation is created equal. Fixed machines are great for fixed tasks. But in environments that shift hourly, where exceptions are the rule and humans are expected to think and adapt on the fly, a humanoid design starts to make more sense. That's exactly what Figure is betting on. Their humanoids are designed from the ground up to be generalists. Robots that can move through the world as we've built it, interact with the tools we already use, and fill in wherever flexible human labor is needed. They don't require custom pathways, redesigned storage systems, or safety cages. That modularity is a competitive advantage, especially in logistics, where cost per square foot and adaptability matter more than ever. And while many robotics companies are focused solely on functionality, Figure is also investing heavily in usability. They've built a foundation using reinforcement learning, vision language models, and simulation to real training environments to shorten the time it takes to teach a robot something new. That means if a humanoid starts its job sorting boxes, it doesn't have to stay there forever. It can evolve with the workflow, just like a human employee would. If UPS and Figure move forward with a formal partnership, it would signal a turning point for humanoid robotics in logistics. It would also challenge competing humanoid developers, like Tesla Optimus, Sanctuary AI, and Agility Robotics, to move faster and prove their own commercial readiness. The pressure would be on to show not just cool demos, but scalable deployments with tangible ROI. At the end of the day, the conversation around humanoid robots is shifting. It's no longer about whether they'll be useful, it's about where they'll be useful first. With factories already dipping their toes into humanoid deployments and tech companies ramping up their AI capabilities, logistics may very well be the next major proving ground. As humanoid robots inch closer to real-world deployment in warehouses and logistics hubs, it's clear they're not just tools for lifting boxes. They're adaptable machines designed to step into human-shaped gaps across industries. And while the factory floor may be the first proving ground, it's far from the last. Because what happens when the same level of robotic precision and reliability is needed in places far more delicate than a shipping center, like the operating room? Yes, robots are closing in on a future that once sounded like pure science fiction, performing surgery better than even the most skilled human hands. The speed, precision, and consistency of surgical robotics are advancing at a rapid pace, and many experts now believe that within just a few years, robots will outperform good human surgeons, and within about 5 years, even surpass the very best. One of the most compelling examples comes from Neuralink, where the demands of inserting ultra-thin, flexible electrodes into brain tissue required a level of precision and delicacy that was simply beyond human capability. The surgical robot Neuralink developed had to operate with micron-level accuracy and speed that no human hand could match. It wasn't just helpful, it was essential. That moment marked a turning point. Some surgeries are already out of reach for humans, and only possible because of machines. While that kind of robotic precision is currently housed in specialized equipment, the question naturally arises: what about humanoid surgeons? Can we imagine a future where general-purpose robots perform complex surgical procedures in typical hospital settings or, more ambitiously, in chaotic, resource-limited environments? Today, that still feels like a stretch. Hospitals rely on highly specialized tools and sterile environments. The idea of a humanoid robot walking into an operating room and conducting surgery unaided still belongs to the realm of advanced research. But there's another angle to consider: adaptability. When natural disasters strike, or during wartime and humanitarian crises, surgeries are often performed in makeshift conditions, sometimes in tents, damaged buildings, or areas with minimal infrastructure. These are precisely the situations where humanoid robots could shine. Unlike fixed surgical systems that require stable installations and cleanroom conditions, a humanoid robot with steady hands and modular tools could theoretically be deployed anywhere. It could assist field doctors, perform trauma triage, or take over repetitive tasks, all while being remotely guided by specialists. In areas where human access is limited or delayed, these machines could literally mean the difference between life and death. Even outside of emergency zones, there's another strong case for humanoid intervention, anytime manual tools are involved. From suturing wounds to holding retractors or manipulating instruments in constrained spaces, humanoid robots could become valuable assistants, or eventually, autonomous surgeons. Their humanoid form would allow them to use existing tools, work within current hospital designs, and integrate into human workflows with fewer disruptions than entirely new surgical platforms. We're not there yet. But with the gap closing rapidly between robotic precision and human expertise, and with AI continuing to improve decision-making, the dream is getting closer. Robotic surgery is already here in specialized forms. Humanoid surgical support may be the next wave, not to replace doctors, but to bring their skills to more people in more places than ever before. Neuralink, the brain-machine interface company founded by Elon Musk, has announced new trials that bring us closer to seeing Tesla's humanoid robot Optimus, controlled by the human mind via Neuralink's N1 implant. This announcement has sent shockwaves across tech and medical communities as it blurs the lines between robotics and neuroscience. Imagine not only restoring lost physical abilities, but also enabling cybernetic superpowers, that seamlessly integrate human thought with robotic functionality. Let's dive into the specifics of this monumental update and explore what the future could look like with this unprecedented partnership. Neuralink recently revealed details about its new feasibility trial, called the Convoy study, which will build on the ongoing Prime study. The trial's main focus is testing how the N1 implant can control assistive robotic limbs. This isn't just a theoretical leap, it's a real-world step toward merging human cognitive abilities with robotic precision. What is the N1 implant? The N1 implant is Neuralink's flagship brain-computer interface (BCI) device. It's a tiny chip that can read and transmit signals from the brain. Initially developed to restore communication for people with neurological impairments, the implant is now being tested for physical freedom, allowing users to control devices like robotic arms directly through thought. This is where Tesla Optimus enters the picture. Neuralink envisions a future where individuals with disabilities can use Optimus's robotic limbs as if they were their own. In July 2024, Elon Musk shared a bold vision for the Neuralink Tesla collaboration. Speaking at a Neuralink conference, he described how people who've lost limbs could use Neuralink to control robotic arms or legs attached to Tesla Optimus. Let's say somebody has lost their arms or legs. We could actually attach an Optimus arm or Optimus legs to a Neuralink implant so that the motor commands from your brain that would go to our biological arms now go to your robot arms or legs, and you'd basically have cybernetic superpowers, Musk explained. This isn't just about restoring basic mobility. It's about transcending human limits. With Optimus limbs controlled by Neuralink, users could potentially lift heavier weights, perform intricate tasks, or achieve feats no biological limb could manage. Progress on design and movement. Tesla has been making rapid advancements with Optimus, focusing heavily on human-like movement and functionality. The robot's limbs, hands, hips, and legs, are designed with an intricate understanding of human anatomy. Optimus's hands now boast 22 degrees of freedom, DUF, making them some of the most advanced robotic hands globally. For context, human hands have 27 DUF. Competing robotic hands often max out at 6-7 DUF. This difference is huge. Jim Fan, a senior research manager at NVIDIA, has praised Optimus's hands for their tactile sensing and robustness, highlighting their ability to interact with objects repeatedly without constant maintenance. Why Optimus is perfect for Neuralink integration. Tesla's focus on natural movement and dexterity makes Optimus the ideal partner for Neuralink. The robot's ability to replicate human biomechanics allows the N1 implant to send familiar motor commands to Optimus limbs. In simpler terms, controlling Optimus's hands or legs will feel just like moving your own. Neuralink's new feasibility trial, the Convoy study, is a pivotal step in linking BCIs like the N1 implant with assistive robotic limbs. Here's what the study aims to achieve. Testing precision control. Participants will use Neuralink implants to operate investigational robotic arms. The trial will measure how effectively the N1 implant translates brain signals into motor actions. Cross-enrolling participants. The Convoy study will build on Neuralink's Prime study, allowing participants from the original trial to test these advanced applications. Restoring physical freedom. The ultimate goal is to give individuals with disabilities the ability to control robotic limbs seamlessly, restoring not just mobility, but also independence. Neuralink's announcement highlights the significance of this step. This is an important first step towards restoring not only digital freedom, but also physical freedom. Stop and think about this for a second. The Convoy study isn't just about testing robotic arms. It's about redefining what it means to be human. If Neuralink and Tesla Optimus succeed in this collaboration, the implications are staggering. For medicine, people with spinal injuries or neurodegenerative diseases could regain lost abilities. For robotics, the line between human and robot will blur, creating hybrid systems that extend human potential. For society, cybernetic enhancements could become the norm, raising ethical, legal, and social questions about human augmentation. Now let's explore where this could all lead. The integration of Neuralink with Tesla Optimus is just the beginning. Here's what we could see in the coming years as this collaboration evolves. Full-body cybernetic integration. While the current focus is on robotic arms, future developments could expand to include entire body replacements. Imagine a world where people with paralysis control fully functional robotic bodies. Soldiers wear cybernetic exoskeletons powered by Neuralink. Athletes use robotic enhancements to push human performance to new heights. This wouldn't just restore lost abilities. It could unlock capabilities we've never imagined. Enhanced cognitive abilities. Neuralink's technology isn't limited to motor control. By reading and writing brain signals, future implants could enhance cognitive functions. Faster learning. Directly uploading skills, like playing a musical instrument or speaking a new language. Memory augmentation. Storing and retrieving memories digitally, like saving files on a computer. Mind-to-mind communication. Sharing thoughts with others without speaking a word. Combining these capabilities with Tesla Optimus could lead to humanoid robots that act as extensions of our minds. Elon Musk has often emphasized the importance of making cutting-edge technology affordable. In the future, we could see mass production of Optimus robots. Tesla's expertise in scaling production means Optimus could eventually become as common as electric cars. Affordable Neuralink implants. Neuralink's mission is to democratize access to BCIs, ensuring that people from all walks of life can benefit. Imagine a world where robotic limbs or bodies aren't luxuries, but standard solutions for physical impairments. With great power comes great responsibility. As Neuralink and Tesla Optimus evolve, they'll raise profound ethical questions. Human identity. If people control robotic bodies, what does it mean to be human? Inequality. Could cybernetic enhancements create a divide between those who can afford them and those who can't? Safety. What happens if someone hacks a robotic limb or body? Governments, companies, and society will need to navigate these challenges carefully to ensure these technologies serve humanity rather than divide it. The announcement of the Convoy study marks a critical milestone in the Neuralink Tesla Optimus collaboration. But it's just the start. As these technologies continue to evolve, they'll reshape industries, redefine human potential, and challenge our understanding of what's possible. What's next? Here's what to watch for in the coming months. Results from the Convoy study. Initial findings could pave the way for broader applications of Neuralink-controlled robotics. Advances in Optimus design. Tesla is likely to continue refining Optimus's capabilities, making it even more human-like in movement and function. New use cases. Beyond assistive devices, expect discussions about integrating Optimus into industries like healthcare, logistics, and even space exploration. The partnership between Neuralink and Tesla Optimus is more than a technological breakthrough. It's a glimpse into the future of humanity. Whether it's restoring lost abilities, enhancing human potential, or creating entirely new possibilities, this collaboration has the power to change lives on a global scale. So, what do you think? Are Neuralink and Tesla Optimus the future we've been waiting for? Or do they raise more questions than answers? Let's talk about it in the comments below. And don't forget to like, subscribe, and hit the notification bell for more updates on groundbreaking tech like this. The future is here. Let's explore it together.